Okay, welcome back again. Now we have what? We have this types 0 multiply infinite, I don't know, x sine of x. So we have as x sine of x. That example. Limit of x sine of 1 over x over what? When x approaches to infinite. Do not forget about that. We should have that idea that here x approaches, we see theta approaches to 0, sine of x over x or theta over theta equal to 1. Here is 0, here's the theta over theta. So for infinite, we cannot solve it. So I'm going to rename that one. First of all, if I substitute, I will get what, Jamaat? Sorry. So it's equal to what? Yes. If I put infinite here, I'll get infinite. If I put infinite here, I'll get sine 1 over infinite. Understood? Was equal to infinite of sine of 0 was equal to infinite multiply 0. And we say that infinite multiply 0, 0 multiply infinite, infinite minus infinite. These are the same, the other type of what? Of indeterminate form. So how we changed? We try to transform that one. We try to transform that things 0 infinite to 0 over 0 or infinite over infinite or infinite over infinite. Understood? That's your duty. So in case you have a second type, try to transfer to the first type. So how? As I said, here we are. I'm going to change that one. I say let h, x, anything, u, v, anything that you have. In your book, you mentioned h. I'm going to use the h. So you can use the u. I say u, let 1 over x be u, like that. So you can see from here, you have h substitution. Okay. Now, limit of x approach to infinite, x sine of 1 over x. Now I'm going to change that. I say let h be what? Be 1 over x. So I'm going to change my formula, my example to h example. Understood? So how? I say limit is limit. Sine 1 over x will be what? 1 over h or h? H. Allah. Understood? So how about x? X is equal to what? How do you know? Here, from here, right? So x is equal to what? Cross it, you'll get 1 over h. Am I right, dears? Do you have any question? Did you understand? You didn't understand, okay. So I'm happy because you didn't understand. At least you say that. So I have this substitution, right? So I'm going to change it. How? We say h multiply x is equal to 1. Am I right? So x is equal to what? 1 over h. I just transformed again. Why? Because I am going to, my plan is what? My plan is what? To change all x to h. So if I have 1 over x, I say is equal to h. If I have x, I say is equal to 1 over h. Understood? Any question? So we change that green zone to that one by here. Clear? Good. Now we have a limit here. Here's a problem. So how I change that one? Yeah. Before we say x approach to infinite. Am I right? Now I say x is equal to what? 1 over h. Right? Or you can say what? You say that h equal to, okay, that one's better. You say h equal to 1 over x. Am I right? So if x approaches to infinity, h will be what? Am I right? Then h will be what? 0. But you know, because 1 over x, if x approaches to infinite from positive part, I will write positive part. Because maybe that one, if it's going to negative part, I say h approaches to 0 from negative part. Understood? Okay. Now, how we change that one? I'm going to repeat that one. How we change that one to 0? How we change it to 0? Because I know h equal to 1 over x. So if that one is going to be to infinite, I'll get 1 over infinite. Then h will be approximately 0. So that's why I'm going to change that one, h to 0 from right side. Now you can compare that one, change it to here, that one, change it to that one, that one, change it to that one. And there is no x in my example, right? You get the idea? So we are going to substitute, yes. 1 over x maybe is like that, am I right? Understood? If x approaches to infinite, we are close to what? We are close to 0 from here, from upper side, right? Or you can say, when we are going to, let me give you some more example. That become a box check. For a question, if I have 1 over x and x approach to 0 from positive part is equal to what? The value. I'm going to here, sorry. I'm going to 0 from positive part. The value will be what? Infinite, am I right? How about if x approaches to 0 from left side? I'll get what? Understood? That's why when we have a positive part, I say x approaches to positive. When we have negative part, I say is it going to be to 0 from left side. You got it? Good. Any question? So my limit is changed to that. Understood? Which that one is easy for you because it look like what? Am I right? It look like that formula. So that's why I can say is equal to what? So you can say is equal to what? That's it. What's going on? What did we do? Maybe you lost the idea. Before, we have infinite multiply 0. Do you remember that? Before we change, we exchange. But now I have what? Am I right? If I substitute, I'll get sine of h0 over h0, so I'll get 0 over 0. That was the idea. Any question? Yes? No. At 20 years, we say that. Exactly. I got a cosine over 1 is equal to 1. We say that. You can solve this one by 2 methods. Formula, because we did it before. We got it in chapter 2. Or, again, L'Hopital. Here, I recommend you to use L'Hopital to be, what do you say, to be in your mind, to be like a repetition. Repetition, that's. And also, you will not lose the idea because why we changed to that formula? No, we didn't change. We changed the second type to the first type. That will be better. So you can use that one, or you can say that one will be h approach to 0 cosine of h over 1 is equal to 1 over 1 is equal to 1. Understood? From here to here. Good. Next example. I'm not actually going to solve that one for you. You can see if I put 0, I will get what? 0 from right side. Look, and graph how you can use the graph for many things. We have a limit x approaches to 0 from left side, ln of x. Can I change this question to like that, to be like that? Can I change it or not? What? Can I change it like that? Huh? Yeah, exactly. We cannot change that example. The question should be logic. The question should be logic. Why is not logic that one, the green one? Because here, if I substitute 0 for here, it's okay. But for here, it's not okay. We haven't ln of 0, but we have ln plus something, right? 0 plus something. 0 plus something we mentioned in chapter 2 means that 0 point may be 0.001, right? So we have ln of 0.001. Yes, we have it, but we haven't ln of 0. That's why I say the question should be logic. So that's why in your book put the ln plus 0 plus. Now, if I substitute, I'll get what, dears? I'll get what? Yes? You can just substitute a bit in it, yes? Right? Again, why? I'm going to 0 from positive part, so the result over y is going to where? Negative infinite. Of course, I'll give you something that we mentioned. Of course, I should give you something that we mentioned. But I think we mentioned many things. So be careful, okay? We mentioned many things. So in that case, I will get 0 multiply minus infinite, right? So it's equal to 0 multiply infinite, the same. So again, is the indeterminate form. For the second type, why? So how we deal with that? We are going to change it to 0 over 0. How? Or infinite over infinite. So how? You can see from here. Now, if I put 0, I will get infinite. If I put 1 over 0, I will get infinite. How we change it? Can you tell me? They? No, you don't need to. It's easier than that one. So x approaches to 0. Then of x, here I have square root of x, right? So I'm going to make it as a denominator. How? Can I write like that? Is true? No, of course no. How about that one? Understood? You got it? So this one, I'm going to bring that one to denominator, but how? I'm going to use the reciprocal. Reciprocal means understood? So I cannot say directly is equal to square root of x. No, is equal to 1 over 1 square root of x. Okay? Maybe your question is why, or maybe my question is why. Why we did like that? Exactly, thank you. So we got what? Here, we bring that one to down, and we got what? When I down, I mean by numerator, we got that one. Understood? Minus 6 Mustafa. Okay, good. Any question? No question? Good. So how we solve that one? I don't know. You know. First derivative denominator and go on. The important things here, the idea. I'm not going to solve for you. You look at your book, you will see. How about that one? Again, the second type is infinite. Why infinite? 1 over sine of 0 is equal to 1 over 0 minus 1 over 0 is equal to infinite minus infinite. So how we solve that one? How? No, I gave you 2 notes here. We say use what and what? Alan? How you solve that one? No. My question is what? Previously, I mentioned two nodes to here. I say you are going to use that one or that one. Do you remember? Share me an example. I need my note. Notek my later. Give it back to me. وتمانشي نوتك معناها لو كيسة وتمانشي شي حاليا. Do you remember? Yes. Yes, later, yes. But my question is what? I gave you two notes on that situation. So what was the note? Conjugate. Thank you. And the factor. Do you remember that? Well, the kisi awa conjugate with a maybe. We don't say 100%, maybe. And what? Factor. What do you mean by factor? So in that case, maybe one. So here we are infinite over infinite. So how we solve that one? We say is equal to what? How you solve it? Yalla. Exactly. Jerry Habosh. Common denominator. Jerry Habosh. Common denominator. So it's equal to what? X sine of x. Probably cross, right? So I'll get x sine of x. Do you have any question about common denominator? Dears? So I'll get what? Now I'll get what? So I'll get again 0 over 0. So how you solve that one? Derivative, you know. It's the first type and you can use the derivative. Easy, right? But the important thing is what? First, to distinguish, to choose, select which type do you have. Then how we deal with that type. That's very important. Now I'm going to solve the last one. We have what? Example 7, let me see. Example 8. And what else? Nothing. So 2 example remains. So pay attention. Let me see. Both are the same. Let me solve the first one. Example 7. How we know this is the first type, second type, the third type is very important. So I have 1 plus x, 1 over x, 1 plus x, 1 over x is equal to what? Limit of x approach to infinite or 0 does not make a sense, both true. You can see positive 0. So is equal to what? That's the question. So how we solve it? First of all, we should what? Substitute. You are right. How about sub? I know. Okay, substitute. So it's equal to? Yes, equal to? Equal to? 1 over infinity. 1 to the power infinity. Thank you. Later. Okay. How? How? Yeah. You'll get 1 plus 0, 1 over 0. Am I right? So you get what? 1 over infinity. Okay. So 1 over infinity. Yes. أينما نوت أجس فرشتي أو أشيب infinity أجا positive أجا negative I'm say minus infinity. This is approach to 0 to the left side. I say minus infinity. Yes. So, dears, do not forget about the notes. Indeterminate. But careful, 2 to the power infinity is equal to what we say? Infinite. E to power infinite is equal to what? Infinite. 3 to power infinite equal to what? Infinite. 1 over 2 to power infinite equal to what? Is equal to 2 to power minus infinite is equal to 0. Am I right? Understood? 1 over 3 is equal to what? 0. Do you know why? Do you know why 1 over 2 is equal to 0 with an infinite power? Because 1 over 2 will change to 1 over 3, 1 over 4, 1 over 5, 1 over, sorry, not over 3. 1 over 2, 1 over 4, 1 over 8. Am I right? So it's going to what? Decrease. Yeah? I will change the see 1 over 2, 1 over 4, 1 over 8, 1 over 16. It's going to be what? The denominator will be larger, greater than the whole reciprocal, or the whole fraction is going to 0. That's why we say it's going to 0. Decrease. We need these concepts actually. I don't care about Cal. Actually, my issues in Cal too, because we need all this information. So careful. Understood here? Good. The same thing is true for here. That's the other formula. But 1 over infinite is something else. 1 over infinite is something else. Careful. Understood? That one is something else. Okay. Now, how we solve 1 over infinite? We say 1 over infinite is indeterminate form. So I have x approach to infinite to 0, 1 plus x, 1 over x. We see equal to, we don't know. Now I say let y be that one. Okay, dear? I'm going to solve that one. Maybe I will leave the example 8 for you. So pay attention. All of them, this type, the power of indeterminate form, they are the same idea. And if you solve one of them, means that you know the other one. Understood? Good. So how we solve it? I say take ln. Look. Take ln for both sides, you know. So ln of y equal to ln of, yeah, before the limit, we can say, let us say y equal to 1 plus x, 1 over x. So I say ln of y, let, is equal to 1 plus x, 1 over x. Step by step. Please pay attention step by step. If you didn't understand any step, please stop me, okay? Just let me know. So we have a ln of y equal to 1 over x ln of plus x. So it's equal to what? So how you do like that? Now it's time to what? To take a limit for both sides. Now substitute. That one is x, that one y. I will get the same. Am I right? Okay. How about the other part? Right side? Huh? Right? Substitute it. Ln of 1, I'll get ln of 1 plus 0 over 0. Am I right? So ln of 1, so I got what? 0 over 0. Well, okay. So how we solve that one? How we solve ln of y, limit x approach to 0, 1 plus x over x. How we solve that one? We did it now. We did it before, right? We did it before, huh? We did it here. Well, so the result will be yalla equal to what? Derivative of denominator 1 over 1 plus x, right? When we substitute here, I will get what? Ln of y equal to what? 1. 1 over 1 is equal to 1. But I gave you what? I gave you y or ln of y. Y. So we are going to take exponential for both sides, I mean. So I'll get e. Understood? So e ln y will equal to e to power 1. And you know e ln y is equal to what? We say that. See these, they are canceling each other, they are inverse to each other. So y is equal to, that's the good answer. Okay. Do you have any question? Please don't hesitate, ask a question. Easy? It's not easy actually, but need work. Need to, at least you should try to solve 3 examples. Okay, good. So, how about the last example? Last example? That one? Yes? Why we use ln? Because we have exponent indeterminate form. We have the power form like that. Now, if I put substitute here, I'll get what? Infinite to power 0, right? So it's indeterminate form. Which type? Third type. It's called power. So how we solve? We should use ln. Otherwise, we cannot deal with it because we should change that one to 0, 0 or infinite over infinite. So how we do it? We should take a ln. Look at here, example 8, please. Yalla, directly, I'm going to solve the example A here. See, we have y, we can say y equal to x1 over x. Ln of both sides is equal to 1 over x ln x, am I right? And take a limit, you say ln of y, here you can say, take a limit, is equal to limit x approach to infinite ln of x over x, right? So it's clear. So I will get what? Infinite over infinite formula. So how we solve that one? Derivative of here, 1 over x. Derivative of here is equal to 1. X approach to infinite. So I got ln of y equal to limit x approach to infinite, 1 over x was equal to 0. You know, it's easy. Ln of y is equal to 0. But I need what? I need y. So I'm going to take e to both sides. That one will be y. That one will be 1. It was quick, fast, but you know, the same idea. There is nothing to think about it. Just do the routines, do the steps. Understood here? Do you have any question? I'll take attendance. Let me stop the lecture.